So here's the third video, the third part of logarithms of the handout I gave you. Hopefully we're all learning. So like we said, when you take log base something of that same something, it ends up canceling out, just equaling 1. So that comes in handy right here, log base 13 of 13. I mean, the logical way of thinking of it is 13 to what power gives me 13? Well, that cancels out because the answer is 1. 13 to the first power is equal to 13. But we just need to start getting used to seeing this right here and just saying, oh, cancels out, the answer is 1. Not even thinking through it. Why? Because you might have variables involved, like on number 2. Log base 5 of 5. Log base 5 of 5 cancels out. So what happens with that exponent of x? It just comes down and it becomes a regular x, and that is your answer. Okay? Now, here's the thing, guys. The logarithm is a logarithm situation is an inverse of an exponential situation. So you see this log base 5? It undid this exponent situation. I don't know if that makes sense. How about this? Let's say I gave you an equation that you wanted to solve. And let's say it was 5 to the x power equals 25. Now, I already know that you guys know that the answer is 2, right? I already know that you guys know that the answer is 2 right there. But let's say I wanted to show some work. Let's say I wanted to solve this algebraically instead of mentally. Well, I want to solve for x. That means I want to get x by itself on one side. What's the problem here? The x is an exponent. Now, I don't want an exponent. And when I don't want an exponent, I'm going to do the inverse of an exponent. And the inverse of an exponent is truly a logarithm. So how am I going to get rid of the base 5? By doing something to both sides on this equation. I'm going to do log base 5 on both sides. Log base 5. So why would I do log base 5 on both sides? Because log base 5 of 5, what happens? Cancels out. My answer is x. And over here, log base 5 of 25, we already know that that answer is 2. Now, of course, you're not going to solve that problem that way. How are you going to do it? You're going to say, oh, 5 to the x. 5 to what power gives me 25? Oh, the answer is 2. But what I'm trying to show you here is that a logarithm undoes an exponent situation. Kind of like an exponent situation undoes a logarithmic situation. Let me give you that explanation right there also. Like let's say I had log base 2 of x equals 3, right? Now, I already know that you could think 2 to what power gives me x? Well, in this case, 2 to the third power gives me x. So my x is really 8. I already know that you guys could rationalize through it and change it to exponential form. But let's just pretend this is a regular equation. There's an equal sign, there's an x. Let's get x by itself. How could you do that? Well, you'd have to get rid of log base 2. Now, how do you get rid of something? You do the opposite. You do the inverse operation. So like I was saying, the inverse operation of a logarithm is an exponent. The inverse operation of a logarithmic function is an exponential function. So right here, if I take this whole thing and raise it up to be the power of base 2. Now, why am I raising this up to be the power of base 2? Because the logarithm has also a base 2. And on an equation, this was an equation. You could do whatever you want to an equation as long as what you do to one side of the equation, you also do to the other side of the equation. Okay? So why would I raise up this side of the original equation to be an exponent of base 2 and raise this side of the equation to be the exponent of base 2? Because when I have 2 to the log base 2, that eliminates itself. It cancels out, and the x comes down. So I truly have an x that comes down, an equal sign, and on this side I have 2 to the third, which is 8. Now, of course, I already know that you guys could solve this mentally because you know how to change the original logarithmic expression to an exponential expression. But what I'm trying to show you here is that a logarithm is the inverse of a power is the inverse of a logarithm. So maybe I got way too carried away with these examples. Let's go back up to what's really important here, understanding the basics. That when you have log base 13 of 13, it cancels out. When you have log base 5 of 5, it cancels out, and whatever's left comes down. On this one, same thing, 3 to the power of log base 3. Because you have the base 3 here, and as an exponent you have log with the base 3, those guys cancel out. And what's your answer? It's just x. Let's do the same thing over here on number 4. 10 to the common log 4. Now when I say common log, that means that it has a base 10 right there. So what happens with the 10 to the log base 10? It cancels out. So my final answer is just 4. Let's move on to number 5. ln of e. Well, remember, what is ln? What does ln actually mean? You could rewrite it as log base e of this guy, which is e, and then to the 2x power. And we know that log base something of that same something cancels out, so your final answer is just 2x. I hope this is making sense. Feel free to pause and rewind if you need to see it again. Number 6, e to the ln. Again, ln is log base e. So we know that that's going to cancel out, and the answer is going to be 7. Showing my work, it would be e to the log base e of 7, and the e and the log base e cancel out, you get 7. Okay. Number 7, sorry. That's a common log, so there's an invisible 10 down here. So log base 10 of 10 cancels out, right? And what's left? Just 7x. There you go. You're done. It's time to get to something more interesting like number 8. Number 8's more interesting because this is a 9 and not a 3. It would be awesome if this was a 3. Why? Because I could just cancel them out. Log base 3 of 3 cancels out. So I want to make it a goal of mine when I see these guys to try to rewrite them. I want to change that 9 to a 3 squared. And of course I'm going to rewrite everything else. The x out here and the log base 3 down here. Now why would I do that? Because I know that the log base 3 of 3 is going to cancel out. But before canceling out, I'm going to actually do a power to a power, multiply these guys, and I want to get 2x. So let me rewrite the whole thing. Log base 3 of 3 to the 2x power. And now I'm going to cancel the log base 3 of 3. So my final answer is just 2x. Now, of course, you don't have to show all of this work, right? I would just write this part probably and then just cancel out the 3's and know that 2 and the x, you have to multiply them so it becomes 2x, and that's what comes down as your answer. Take a look at number 9 here. It would be awesome if this 16 could be written as a 4, and it could. 4 squared works. So 16 is really 4 to the second, and I still have the outside 5x, and I could still bring down the log base 4. So what happens with the log base 4 of 4, I'm not going to show my work here, I'm just going to shortcut it, cancel that out, and remember, a power to a power you multiply, and that power comes down as a regular term now, and you get 10x as your final answer right there on that one, number 9. Moving on to number 10. What do we have here? We have 5 to what power gives us 25, right? You could think of it that way if you want, or let's think of it this way. It would be really nice if this 25 were rewritten as 5 to a certain power, and might as well write it as 5 squared with the x out here. Bring down the log base 5, and the log base 5 of 5 cancels out. And what about that power of 2 and the power of x? You multiply them and you get a final answer of 2x. It's not an exponent, it's just a regular 2x. Moving on. 2 to the log base 22, we already know cancels. What's your answer? 6. Piece of cake. 6 used to be an exponent, now it's just a regular 6. 81. Let's rewrite 81. Now some of us are thinking 81, oh, 9 squared. Okay, that's great, 9 squared. But what do I really want? I don't want a 9 as a base. I want a 3 as a base. That way, it'll be able to cancel out the log base 3 with the 3. It'll cancel out, and I'll be able to just drop down whatever I have up here as my final answer. So 3 to the first power is 3, 3 to the second power is 9, 3 to the third power is 27, 3 to the fourth power actually is 81. So I'm going to rewrite 81 as 3 to the fourth. And of course, like I said, those guys cancel because it's equal to 1. And these powers, you have to multiply them. Final answer will be 16x. Let's move on. It gets a little more interesting here. I know you're probably thinking, how could it get more interesting than this? Check it out. Number 13. Actually, this one's pretty easy. 64 could be rewritten as 2 to the 6th power, I believe. So we have log 2 of 2 to the 6th power to the x. Final answer is 6x. Why? Because log base 2 of 2 cancels out. And the power to a power, multiply them, you get 6x as a final answer. 14 is interesting because right here I have log base 2, and it would be nice if I didn't have a 1/8, but if I actually had a 2. Now, how the heck am I going to change a 1/8 to a 2? 2 to what power gives me 1/8? That actually could be done. 2 to the negative 3 power gives me 1/8, right? So you guys need to get comfortable with negative exponents here. 2 to the negative 3 gives you positive 1/8. So all I need to do is multiply power to a power. These guys cancel out, and I get negative 3x as a final answer. Guys, please post questions if you have any. Please watch these videos as many times as you need to make sense of them. There will be a sub on Tuesday, and you're going to have to do this exact work on Tuesday, okay? So ask questions right now, over the weekend, if you have them.